Hi guys. A z-score is a really simple tool for making a comparison. So in our 2017 class data, we had 2017 math class sizes. We had a math class size of 29. And we also in 2017 had an English class of size 29. So we can see those in our data set. So here is the 29 in the math data set. Here is the 29 in the English data set, but 29s are not always 29. In this case, this is a 29, but it is a math classroom. This is a 29, but it's an English classroom. So these class sizes of 29 actually represent something a little bit different if you consider the other characteristics of these distributions. So here is the idea. A math class of 29 and an English class of 29 aren't the same distance from their own means. And these distributions also have different standard deviations. The tool to deal with this is called a z-score. So a z-score is just an observation minus the mean for that observation divided by the standard deviation. So notice the observation minus the mean. The observation minus the mean has its own name. This is called a deviation. So all that a z-score does is figure out how many standard deviations will fit into an observation's particular deviation. So look at the math class size of 29. If I take the observation of 29, the mean for the math classes that we calculated was 23.7. The standard deviation for the math class sizes was 6. So if we take the 29 minus the 23.7, that gives us a deviation of 5.3. So a z-score just tells me how many standard deviations, how many of these 6s will fit into that 5.3. Well, if you take the 5.3 and divide it by 6, you get about 0.88. So 0.88 standard deviations fit into this observation's deviation. What that says is the math classroom, the math class of size 29 is 0.88 standard deviations. Above the mean, above its mean. So I know it's above because this z-score is positive. If you ended up with a negative deviation, you would get a negative z-score. It would be below the mean. So for that English class, notice that English class of size 29 has a slightly different characteristic. Look at this, that English class of 29. If we take away the English mean of 25.4, and if we divide by the English standard deviation of 5.3, notice what this tells us. The 29 minus 25.4 is 3.6. If I divide that by 5.3, that gives me about 0.68. So what this tells me is that the English class is only 0.6 standard deviations above its mean. The English class of size 29 is 0.68 standard deviations above its mean. So you can compare these class sizes. Even though a 29 seems like a 29, it's not in context. Notice the math class size of 29 is more unusual. It is farther from its mean. It's 0.88 standard deviations above its mean, whereas the English class of size 29 isn't as far from its mean. It's only 0.68 of a standard deviation away from its mean. So z-scores help to make ideas or distributions that have different means and different standard deviations. Z-scores help you make comparisons between distributions that have different means and different standard deviations.